All right, I'm going to show you all of the calculations that are necessary to find the standard deviation for a sample. We're going to use the data set that I had for in class today for section 6B, which was the heights in centimeters for the first 11 US presidents. If you push the stat button and edit or 1, you'll see that I've got those 11 values right here. You just scroll down. 188 was the height of President George Washington, and this 173 centimeters is the height for the 11th president. You'll notice it says L sub 1 of 11, so that's the 11th value in the list. In order to be able to find the mean, which is necessary, I'm going to go back to the home screen and ask the calculator to sum up all the numbers in that list. To get to the sum command, you push second stat to get into the blue list operators. Over in the third pull down menu, math, option 5 says sum. You don't have to scroll down, you can just push the number 5 and it will paste the sum command. The sum of all of those 11 presidents' heights in centimeters is 1946. We're going to need that later on. But if we divide it by 11, that's a way to find the mean. We'll go one more decimal place accurate than all of the whole number values, so the mean we'll use is 176.9. I'm going to store that into the variable m for obvious reasons because it's the mean. I use the store button above the on button and push alpha divided by, because above that is a green M. From now on, it will use 176.9 in M's place. So if I push edit and go back into the list operator, I'm going to go over to list 2. It has to be the top of the list above that T table, and push enter. And I'm going to ask for all the numbers from list 1, which is second 1. You see it in blue, it says L1, minus that mean value that I stored into M. And it will subtract the mean from all those values. Remember that the squares of those values are used in the first formula for the standard deviation. So if I hover up to L sub 3 and push enter, I'm going to ask for all the differences that are in list 2 and ask for them to be squared. And it'll automatically square those. The formula uses the sum of those squares of the differences between each of the data values and the mean, which is in list 3. So if I push second stat and over to math, using the sum command, now on list 3, I'll find that that is 794.91. Remember that the formula for the standard deviation, the sample standard deviation, is the square root of the sum that we just found of the squares of the differences between each of the values and the mean, all divided by what's called the degrees of freedom, which is n minus 1. Remember, there's 11 items, and that's stored into n, so 11 minus 1 is going to be 10. This finds the standard deviation, and rounding to the closest tenth, it would be 8.9. An alternative way to find the standard deviation is to use this sum of x and the sum of their squares. So if I ask for list 4 to be all the data values that are in list 1 square, it will square all those values. And I'm going to go back to the home screen and ask for the sum of all the numbers in that new list, list 4, which are the sum of x squared. The formula is a lot more involved for the alternative formula, but it does only require the sum of x and the sum of x squared is used. So we really only need 2 columns. The formula is the square root of n times, I'll put it in parentheses, 11 for n, times this sum of x squared, which we just computed. By putting the 11 in front of that number in parentheses, it means to multiply it. I'm going to subtract from that the square of the sum of x. The sum of x was 1946 earlier, and we'll square that. I'll put a close parenthesis, which will finish off that numerator. And I'm going to divide it by all of the denominator, which I'm going to open with 2 parentheses because it's the quantity. Actually, I only need 1 parenthesis. 11 times the quantity 11 minus 1. It's n times n minus 1 in the denominator. So you notice that that gives the same standard deviation of 8.9. A nifty set of commands is also using in the calc command off of the stat. If you just push stat and go over to calc, the one VarStatsC command is very powerful. If it works on our list 1, I'm going to paste that back to the home screen, and it automatically computes the mean, the sum of x, the sum of x squares that both were used in the formula for finding the standard deviation of the sample, which is S. Don't confuse it with sigma. That's the population standard deviation. And as we scroll down, it tells us the n value of 11, the minimum, quartile 1, the median, quartile 3, and the maximum, which are all used in the 5-number summary. And we can visualize that with a box plot. So if we push not y equals, but second y equals, I'm going to go in. And usually I use these stat plots for scatter plots. I am going to turn this on, but I'm going to go down and select the box plot or box and whiskers. And it will operate on that list one and do the box and whiskers in a navy color. I do want to zoom in on the stat plot, so it's important after turning the stat plot on to push zoom 9. And there's our box plot, or our box and whiskers, and we can trace on it, starting with the minimum value, quartile 1, median, quartile 3, and the max. The graphing calculator uses the method for finding the quartile 1 and quartile 3 by finding the middles of the first and the second half, excluding the median from the first and second half when n is odd, which was the case here.